Cool. So the recording has started. So hey everyone, good evening. And I have Rajat with me here. Rajat is a friend of mine from college, and we have known each other for quite some time now. We do have a regular bit of research discussions as well. But yeah, I would let him introduce himself. So over to you, Rajat.
Sure. Thanks, Bose, for this brief introduction and for the invitation, obviously. So, yeah, I am Rajat Bhattacharya. I am currently working as a pre-doctoral research fellow at TCS Research. Previously, I was a software development engineer at Parallel Wireless, where I primarily worked on 5G and 2G access stack development, and I graduated with a Bachelor of Technology in Electronics and Communication Engineering from Indian Institute of Information Technology Guwahati in 2021. So yeah, that's a bit about me. So and right now, after some days, I'll be moving towards my PhD at the University of California, Irvine, uh, basically in computer science. Yep.
Great, great. So how's the feeling? You will soon be an NRI. So how's the feeling?
Yeah, it's. I mean, it's mixed feelings definitely. I mean, you obviously have new experiences, and but again, you leave your family behind, and yep. So
Sure.
that's and so yeah, you've got to trade off, right? You've got to trade off in everything. So we have to see
Got it.
how it goes.
Got it.
Yep.
Cool, cool. So tell me about. We'll definitely move to your PhD, the thing that you'll be pursuing when you're in the US. But tell me about your TCS experience, like the one that you were pursuing up till now, and even parallel wireless. So you start off with TCS Research because we see there's a notion that TCS is the mass recruiter in the company. So like in most of the company in the colleges, TCS would go and just recruit as many students as possible, and there's a myth that I'm not sure if it is a myth or a fact, but the pay is like peanuts. So I'm not trying to defame any company right now. It's just that what I have heard from other people. But since you are a TCS research, so tell me a bit about it. Like, how is it different than the generic TCS recruitment that is done, and what kind of work do you do there?
Sure. I mean, very good question out here. I mean, even I see a lot of posts and videos going on, from TCS to Google, from TCS to Microsoft, or, some kind of from TCS to some Fang or manga, whatever you want to call it.
Yep.
So, but I mean, yeah, it's not a fact. It's a myth that TCS pays peanuts, and you know uh, it's generally a mass recruiter. The 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 uh, the recruitment in TCS research is very different to what, say, you would have in a general role, maybe in a general engineering role at
Okay.
TCS. So it's like this that TCS research comes directly under the CTO,
Okay.
and what happens is that there are various research areas that people are working in, say systems or AI, or there are subdivisions of AI people are working in. So some are working in medical AI, some are in NLP, some are in media and, say, signal processing, various kind of computing stuff. And there are high quality people out there. I mean, you have people who've been professors at IITs before their their tenure at TCS Research, and they're working as scientists there. Then people who've done their PhDs abroad also, even they're working as scientists there. And in TCS Research, the pay is extremely good. I mean, it's extremely comparable to, say, even a Fang or a manga, whatever you want to call it.
Got it.
So, I mean, it's
Oh,
really
that's
a myth. So,
that is reassuring for our viewers, I guess. For anyone looking to get into a research role in India, I guess then TCS Research would be the way to go. But tell me, like, what's how do you, like, you mentioned that the recruitment is different, like the interview process is also different. So, like, what is the baseline? Like, what is needed? What is expected out of a candidate, and how do you apply to TCS Research?
Sure, sure. So generally, what happens is that TCS Research, from what I know personally, I mean, I'm not claiming anything. So TCS Research visits only tier one institutes like IITs, IIITs, NITs, and BITS and those kind of institutes. Um,
Okay,
uh, and the recruitment is majorly of the students that are graduating from those institutes or maybe have graduated earlier uh, with a bachelor's or master's degree. So
sure.
I'm not taking up the PhD people. I mean, let's just keep them different for now.
Hmm.
So if you have a bachelor's or master's, you would be generally recruited as a researcher or a pre-doctoral research fellow in case you want a limited tenure and are planning for a PhD uh, forward. So what happens is that one is obviously the campus recruitment thing, but it's extremely obvious that TCS Research won't be visiting every IIT, every NIT, and every triple IT, right? So maybe some selective institutes they are visiting. But again, you have LinkedIn, right? So you can leverage LinkedIn for a lot of your career search options. So there are many scientists and executives from TCS Research who are there on LinkedIn, and they post that they have an opening in their group or maybe a related group. So you can directly message them or email them some with your past experience and you know whatever research experience you have,
Got
and
it.
basically your entire profile, and
So,
they would
so,
see
so,
if it is
so
a
if I,
fit.
if I'm assuming this correctly, it's not that different from like applying to any other big company, right? You like send a cold email to recruiters.
Right, right. So I would say for me, what happened is that my manager put
Mhm.
out a LinkedIn post that they were hiring. Um, and I just happened to email him just a cold email with my profile that if you would be willing to conduct an interview for me, and yeah, he reached out, and I had one long interview. I mean, rather than having three short interviews. So I had one long interview, and it basically focused on my research experience and other computing stuff. So you know how the general interviews go, but
Got
a
it.
bit more inclined towards research. So yeah.
Sure, sure, sure. So tell me, like, what was your research experience? So when you say that research, because it's TCS research, right? So I'm pretty sure the recruiters would be expecting some kind of research background from the candidate that they are uh, recruiting. So what kind of research experience is needed? Like, what level of research experience? Because people might have, people might be working on person projects and they might term it as research, but then there are people who really grind through it and publish papers across conferences. So what would you term as research good enough to get into TCS research?
Right. So it's a very subjective question, is what I feel. I
Hmm.
mean, there can be, I mean, if you look at it publication wise, I mean, somebody can have one great publication and someone else can have, say, three mediocre publications.
Got it.
So how would you actually compare them? I mean, so that's when the interview comes into play, and once you're interviewed, so whoever is interviewing you, so I had four interviewers, I mean, in one meeting. So uh, so that is where they kind of take the call after uh, you know taking your interview, that whether or not to take you. So
Got it.
if I just go towards my research experience, so across my undergrad, I worked on approximate computing.
Okay.
So approximate computing is basically an emerging computing paradigm that focuses on uh, basically a trade-off between efficiency and accuracy.
Okay.
So, and it can be applied to all kinds of error-resilient applications such as say machine learning, image processing, signal processing, and stuff, where a small amount of error doesn't impact the end application drastically. So that
So I'm
yeah,
a bit intrigued here. So, like when you say machine learning, so what kind of approximate computing would you do there?
sure, sure. So say So let's take an example. Say you're doing clustering, right? Say
Okay.
you are doing k-means clustering.
Sure.
So if you so the there will be operations such as addition, multiplication that would be going on
Okay.
in that kind of an algorithm. So what happens is that those arithmetic operations take up a lot of energy
Hmm.
towards their execution. And when we approximate such operations, so we are saving both on-chip area and power. So when I say we are approximating those operations, we are basically uh, changing the accurate circuits into approximate ones in
Okay.
order to get the approximate results. And we've done some work in this domain.
Sure.
So if you look at some of our previous work, you'll see that we've presented results that we saved a lot of energy with just
So
say
when you say
around
your, so when you say our work,
0.5.
you mean your work, right? Your research experience
Yeah,
or your
yeah,
publication.
my work. Yeah. So I mean, I try to be
Sure.
very. Uh,
Sure. You
I try
send
to be
me
nice here
send
because
across
it's
the send across the links to the publications. I will like put them down in the description of this video for people to check out. But
sure,
so
sure.
so if I'm getting this correctly, when you say approximate computing, these are like hardware level optimizations that you do, and you basically modify the chip in such a way that it approximates the computation rather than trying to give you the full precision output. Correct?
Correct, correct. You are correct. So that is where we do it. So basically, this can be done at two levels. First, obviously, we check if the application that we are taking into account is really approximate. I mean, if the application is if the application can be approximated
Sure.
or not. So that is generally done at the software level first, so that we can validate. And finally, we move to the hardware level so as to analyze the performance gains that we get by approximating such operations.
Got it. Got it. That's pretty interesting. So I'm assuming that since your research experience is very much aligned with, as you mentioned, like it's proper hardware engineering, right? And in India, we see that hardware engineering is something that is juxtaposed with maybe a person working in electronics. So now you come from an EC background. I see that you are going from a PhD in CS. So why that switch? Or like let's start off with EC. Like how was your EC journey? Like electronics, like being from an electronics background, like what was the journey like in college? And I mean, we see that even on YouTube and even in colleges, and when I talk to students, everybody's trying to pursue the computer science background because apparently that has the highest amount of job prospects in the country, because everything is getting automated with AI coming in. Everything is getting automated. You have to know how to code and you have to know how to run software. So it's an easy choice. But since you were in electronics, what was it like, and how did you find your niche, if I were to put it in that way?
Sure, sure. I mean, very good question actually. So, I mean, honestly speaking, I think you would agree with me on this that we are in 2023, right? So,
Yeah.
I don't think there are any boundaries as such uh, towards say domain specific boundaries or anything. I mean, boundaries have blurred, right?
Sure.
So
Yeah.
everywhere we are saying say systems being used for say AI acceleration, or AI being used for making systems, or we are having a hardware software core design kind of thing. Then a lot of things out there. I mean, it's a sea
Yeah.
out there.
Yep.
But
Yep.
yeah, so if I yeah, so let's come. Maybe I'll state it point wise. So what was it like being an EC student at say IIIT Guwahati, right?
Hmm.
So I mean, um, I think you would also agree with me on this, that studying in an institute of national importance can provide with a plethora of resources and opportunities, and you need
Definitely.
to
Yeah.
know how to use them to your advantage, right?
Hmm.
So IIIT Guwahati had, I think even today has ample opportunities and resources that I didn't realize initially. And of course, there's a huge bureaucratic procedure behind everything. But I mean, let's be
Yeah.
real. We are in
Definitely. I mean,
India.
it's there everywhere. Yeah.
Yeah. So yeah, almost every compatible institution has those problems from what I've seen or even heard from friends across institutions. So yeah,
But but
but
but what just to cut you there, what I actually wanted to understand was that you, let's say that you get into an electronics branch, right? And then you, do you get that FOMO that, hey, I might not get a job which is as highly paid as a SD1 or SD2 at Amazon, maybe? Because I'm in the electronics background, I don't do DSA all day. I work with VLSI, so my future is a bit dark over here. So, like, did you get that, or like, and if you did not, then how did you find your niche? Like, how do you know that, okay, this is what I'm going to do, and this is what the outcome is going to be?
yeah, so let's be real. I mean, when you just enter your institute, I mean, say, how old are you? 17, 18, something like
Sure.
that,
Yeah.
right?
Yeah.
Yeah, that's when you're in your first semester. And basically, you do not know anything at that time.
Of course.
And
Yeah.
you're hearing all around that, oh, EC, oh my God, you are done, man. I mean, there's no prospect and all that. Obviously, you're scared. Initially, you're
Definitely.
scared.
Happened to me as well.
Yeah, so
So,
that is, I guess, common across all institutions out there.
at least in India, at least in India. I mean,
Yeah, at
I
least in
wouldn't say
India.
right now, but yeah, at least back then, like 2018, 2019, 2020.
Yeah, yeah, exactly.
Might be
So
there also. Might be there also at the moment. I'm not sure.
yeah,
Might be.
yeah, even now, say, I think I was speaking to a junior, and they were having this doubt that whether, we should continue uh, in EC or switch to CS or what. I mean, yeah. So okay, let's get to it.
Sure.
I mean, the thing is that what happens. I mean, okay. So initially, obviously, I did not have any idea, and I tried switching to CS after after my first year,
Okay.
but unfortunately, I missed out on the GPA competition as my GPA was on the lower end,
Okay.
so I could not. So
Pretty sure that sucked initially.
yeah, that time I was gutted. I honestly speaking, I mean, so so yeah, but I feel all in all, what happened turned out to be beneficial for me because in the first semester there was this course of digital design. Then
Okay.
in the second semester there was this course of computer organization,
Hmm.
and these two courses were taught brilliantly by the faculty members who were taking the courses.
Sure.
That is when I thought that, this is where I want to focus my energy in, and this is what I maybe would want to do for the foreseeable future.
Got it.
So, but uh, my actual uh, research experience started when I started at IIT Roper during
Hmm.
my internship at the end of my sophomore year. So at the end of my sophomore year, I was at IIT Roper. That is where the faculty member who I was interning with introduced me to approximate computing.
Okay.
And I was tasked with designing an approximate multiplier.
Hmm.
So that is where think I found my calling, and I've been doing approximate computing ever since that time.
Got it. Got it.
So
So yeah, that internship was a
yeah,
changing
that was
point
the
for you.
main
Turning.
catalyst, actually, I would say,
Hmm. Sure.
towards. I mean,
Sure.
I tried checking on some Verilog videos, and I mean, I guess you would remember. I asked you, so I'm interested in these kind of stuff. What should I
Yeah.
do?
Yeah.
You suggested, maybe look at Verilog. So I had a look at Verilog, and eventually I happened to get that internship.
Yeah,
And
but
I would
yeah,
say,
I would actually totally agree with you. Like even now, right? It is never about the tech. I wouldn't say it's about the technology, or like really about the programming language when it comes to any kind of thing you want to work on. So it's more about the concept. So if you feel that okay, this piece of technology is something that interests me, then I don't think that a programming language or any particular specific uh, like construct would prevent you from learning that. I mean, if you
yeah,
want to learn
exactly.
like yeah, if you want to learn maths, I mean, if you want to learn math and if you want to do some kind of something related to mathematics, then I mean that's what you want to learn. Then you wouldn't worry about what programming language or anything else that you would have to like grind through. So yeah, I guess it's about that calling which you find interesting at the end of the day.
Yeah, exactly. I mean, even now, when say, even you would have the similar experience. Say, we are, once we are working in the industry, any day, anything. I mean, we can be tasked with uh, working on any kind of technology, right? Any
Sure. Yeah. I
language.
mean, yeah, exactly. It's all about solving the problem at the end of the day. I mean, I wouldn't go and like start thinking that hey, I would learn. For example, let's say there is a very popular language called Rust, right? Which
Mhm.
is extremely fast and optimized, and it has like speed as comparable to C, C++. But I wouldn't like somebody if somebody comes and gives me the problem, I wouldn't be like, hey, I'm going to learn Rust and use that programming language to solve this problem. But instead, I would like try to solve the problem in the easiest way possible and then try to optimize on top of it. So it's not the other way around. So you
Right,
just
right.
try to solve the problem, try to like uh, latch on to the lowest hanging fruit first and sail through it, I guess. So it's all about problem
Right.
solving at the end of the day, any stream you belong to. So yeah, yeah, I guess
Exactly. I mean, you can be a chemical engineer and you can well be working in VLSI. So it's all up to you. So
yeah, I guess yeah. I mean, as you mentioned, like it's the problem statement that intrigues you at the end of the day, right?
exactly.
Yeah, cool. So
So
so yeah. So coming out of EC now, let's say that you understood like what your calling was, and so let's talk about like job prospects in the country. So we know that there are a lot of startups coming up these days who want SDs, software engineers, right? But what about those folks who are specifically in that domain, who have a background in Verilog, VLSI, digital design, computer architecture organization, all those kind of stuff. So, like, what kind of jobs are out there, and how should one approach those listings?
sure. So right now, like say if I take IIIT Guwahati, so I saw some of the 2023 grads getting into hardware companies like ARM, and Western Digital, and stuff like that.
Okay.
So jobs are definitely out there.
Okay.
Obviously, I wouldn't say uh, those are plenty in number as compared to say software engineering jobs, but
Mm.
that's where we need to say uh, we have to be flexible, right? I mean, we cannot like stick to something and say, okay, that is what I'm gonna do for my entire life, because once you graduate, how old are you? I mean, you are just say 20, in your early 20s,
Yeah,
right?
21, 22. Yep, yep.
Yeah, so early 20s, it's time to explore. I mean,
Sure.
we, we shouldn't be like hell bent on, okay, I just want this role, and if I'm not getting this kind of role, I'm not going to do it. No, I mean,
Agreed.
if
Yeah.
you take my case, I was very well interested in digital design and computer architecture and those kind of stuff. But unfortunately, I could not find any suitable opportunity during my time. I
Hmm.
mean, when I graduated, uh, I started out in communication networks.
Okay.
Though in software development, but yes, in communication networks. So
Got it.
it's,
Got it.
I mean, I feel that people should be flexible and accepting towards everything, and not have a preconceived notion that okay, this is good, this is bad. So yeah, that's what it is. I
Got it.
mean,
Yeah,
experiences make
I
you
mean,
who you are, right? Yeah.
yeah, yeah. In your early 20s, 30s, I guess that's the time where you can actually learn a lot of stuff. I mean, you shouldn't restrict yourself to, this is only the thing that I'm going to work on. And yeah, I mean, I guess it's changing right now. I see a lot of engineers from different domains, like even Android engineers trying to learn machine learning, and the other way around. I see like people in the data science domain and AI domain trying to learn how backend systems actually work. So it's more about trying to understand how systems work um, as a whole, instead of just knowing like, hey, this is what I know, this is what I'm going to do. I don't know anything outside this world of mine. So I guess that is something that needs to change for
Yeah,
people to
yeah,
become better
that
engineers.
mentality has to change. I mean, I mean, I don't know. I mean, I'm gonna talk about a person. I don't know him personally, but uh, I know that he has a PhD in chemical engineering.
Hmm.
But he is an extremely good VLSI engineer. I mean,
Okay.
so that's where you see it, right? I mean,
Yeah, yeah.
that's it.
I mean, you see a lot of people coming from arts, math, and becoming extremely good in AI and computer science. So,
Yeah, yeah,
uh, if I'm
there
not
is a
wrong,
professor.
if I'm not wrong,
I
even Geoffrey Hinton had a bachelor's in arts in, I'm not sure, was it psychology? I'm not sure. I have to look it up. But he is the father of neural networks. So
Yeah,
I
so
guess that's important.
yeah, I just saw a profile that is some professor from Israel. She had a bachelor's and master's in biology, but
Hmm.
now like she is a great researcher in digital health and AI for healthcare. So yeah,
Yeah, I guess like things overlap, and ultimately, I mean, you should be. I guess people, engineers these days, they should be the one on the lookout for these opportunities and be able to connect these things together. Cool.
definitely. I mean, it's all about connecting the dots, right?
Yep, yep, yep. So yeah, so like let's talk about your first like job landing, right? Parallel wireless. So you mentioned that you were working in communication. So how did you land that job? Like you mentioned that it was not something from the campus. So what was the process like? How did you apply to it?
Again, LinkedIn helped me.
Okay,
So
cold
LinkedIn helped
emails.
me.
So
Uh,
all viewers who are watching, this is the ultimate truth. There is no shortcut to this. You just have to send out emails. I mean, I am. This is not a joke, but that's what I did also when I was on the lookout for jobs. I mean, you just have to send emails as much as possible, and you cannot be disappointed if you get rejected. I mean, because the conversion rate is extremely less. So
yeah,
I
definitely.
totally
I mean,
concur on that point.
you apply to 100 jobs and then maybe you heard from three or four of them. So
Yeah,
yeah,
I mean, the
we shouldn't be.
conversion of yeah, so the conversion of cold emails is as low as the acceptance to like Ivy League colleges. I guess it's on par. It's a single digit percentage, I guess.
Yeah.
So
So yeah.
so tell me, like, uh, why the switch to CS? So
Um, okay. So actually, this is also a funny story. Actually, so when I was looking out for potential advisors, who I could email to advise me in my area of interest.
Okay.
Um, I found, yeah, obviously I found professors that were there, and the professor that I applied to um, at UCI,
Hmm.
his primary department happened to be computer science. I mean, it's just something that
Okay.
happened to be there. I mean,
But how did
nothing special.
you? So how did you? So when you say like you were looking for advisors, so how did you reach to this conclusion that hey, I'm going to do a PhD, or was it always your plan?
Okay, so it's like this that since during my undergrad I started working on approximate computing, and I delved into this area of research, and I felt that that is something I enjoyed. So honestly,
Okay.
so that is something I enjoyed, and that I think I would want to do uh, across my lifespan probably. So that is when so when I was in my third year of engineering,
Yeah.
so I thought of applying for PhD programs,
Okay.
but not immediately, because for me the case was this that initially my GPA was extremely low. I was
Mm.
suffering from clinical depression,
Okay.
and I would have to thank a, a professor of ours actually, who
Hmm.
helped me reach right treatment in time so that I could save my academics.
Okay.
So eventually, as I sought treatment, and I started getting better, my grades started improving, and if I would have applied at the end of my fourth year, the thing that would have happened is that my cumulative GPA would be taken up to my sixth semester, right?
Okay.
So up to my sixth semester, my GPA was not good. So it was like this that I want to go to a good university for my PhD rather than settle for something substandard,
Hmm.
because you're gonna do PhD once in your life, right? I mean, a
Sure.
lot of people can do 2 or 3 PhDs. It's up to them, but that's the general notion. You do one PhD. So that is when I thought that okay, let's do one thing. Let's go to industry
Hmm.
for maybe a year or two,
Hmm.
and we'll apply for PhD during that time. I mean, during the time I'm in the industry.
Okay.
And also, industrial experience gives you a chance to work on real problems, right? I mean, in your institution, you are always facing, I mean, mostly theoretical stuff. You do not know where or how is it applied, even if is it relevant.
Yeah. Yeah. Yeah.
Right. I guess everyone has this kind of
Sure.
a
Sure.
problem
Yeah. Yeah. I have. I
mapping it.
have been through it. Been through it as well. Yeah.
Yeah, so it was like this that if I want to have a really fruitful PhD experience, I guess I should have some some kind of industrial experience before that, so
Hmm.
that I can work on real problems during my PhD, and have a wide breadth of knowledge that I gather from the industry, right? I
Got it.
mean, I don't know if you've also felt it. You learn a lot in the industry. I mean, if you're working, when I was at my first job, during the initial months, I mean, I think I learned what is taught worth a year in a university,
Yeah.
and
Yeah.
that too practical stuff. So uh, so since as you learn a lot, you learn a lot of new stuff, and that's when you feel that okay, maybe I can gear my PhD towards something fruitful.
Sure.
So what happened was that during my first job, that is at Parallel Wireless, I started again cold emailing professors. So yeah, so I searched for heroes in my field
Okay.
of interest, and and I just sent them cold emails that, if you're having an opening for a PhD position, and I'd like to hear back from you, and mentioned a bit about my profile, attached my CV, and I just kept on waiting. I sent across many emails. I mean, I guess I received, I think, five or six replies.
So
So
yeah, so just a disclaimer, or I should say one more point over there. I will just reiterate over this. So cold email is the only way you get like access to world class education and opportunities. I mean, of course, recruiters might reach out to you as well, but then again, cold email is something that always works if you stick to it. But yeah, I guess that's one takeaway from this podcast, at least, if nothing else.
so yeah, so from my I mean, I heard back from my current advisor a month later. I emailed him, so
Okay,
that and he scheduled a call a month later, his reply.
okay,
So you need to plan around well in advance, right?
got it. And
Otherwise you would be.
were there interviews as well? Like once you heard
I
back from
mean,
the
it was
process.
like you have your PhD interviews, right? So
Got it,
that kind of an interview.
got it, got it. So
You
mostly
give your.
around your
Yeah,
research, right?
exactly, around
Got it.
that and your background and stuff like that.
Sure,
So
sure,
that is
sure.
when, and that is when my professor advised me to apply to the CS department.
Hmm.
So because his primary department was CS and he had a joint appointment in ECS.
Okay,
So in case I would find any kind of funding issue, then he could take care of it if I was in the CS department. So
acha.
yeah. Um,
So how is CS different from ECS? So are the subjects different, or like what happens there?
So it's like this again, reiterating, there are no boundaries. I mean,
Yeah,
so you can, I mean, everything is mixed up right now.
sure, sure.
So obviously, there are some subjects that are there in CS, not ECS, and vice versa. Like,
Hmm.
say, you would have something like digital signal processing in ECS, but not in CS.
Okay.
um, but you would have something like compilers in CS but not in ECS. So
But if you're but if you're in ECS, won't you be able to take the subject, or like how does
like,
that work?
yeah, you can take, you can, if you want, you can obviously take the subject with a written yeah, you just need a small, kind of written thing from your
From your
advisor,
prof.
and you will be
Okay,
able to credit
got it,
it or audit
got
it
it,
or whatever you want to do it about it. So it's all about the university norms and stuff. So yeah. So also, like, it's very important. I see people getting lost in this sea of knowledge towards applying for PhDs. Is that whether to look for universities or advisors?
hmm,
Well, I mean, the answer is out there, right? I mean, you have to look for advisors, not
got it.
universities. You're going for a PhD.
Yeah, yeah.
Your advisor is the one who you will be spending, uh, half a decade with, probably,
Hmm.
and the group that your advisor is leading.
Makes
So
sense.
it's not about the university, it's always about the advisor. So that's when you need to find out, which kind of advisors you want to apply to, and just go ahead with your applications. And in case you're in doubt, you should also speak to some existing graduate students in the professors group, so that you can get a brief idea about the
Got it,
his leadership style and stuff like that. So
got it,
yeah.
got it. Makes sense. So now tell me one thing: why a PhD in the US and why not a PhD in India in the top IITs or the other colleges that we have?
I mean,
So
yeah.
let me add
So
to that. Let me add a few more bits to that question. So is it because of research expertise and advancement uh, over there, or is it something else? Like you want to move to the US? What's the deal there?
okay, sure. I mean, uh, I would say in no way is Indian research inferior to the research done in US.
Sure.
I mean,
Okay, thank you for
people in
saying that.
India,
Thank
yeah,
you for saying that and clearing the air.
yeah. I mean, people in India are doing tremendous work. I mean,
Yeah.
so the great people out here in IITs, ISC, or even any kind of top tier institutes you go to, and
Got
they
it.
are having sufficient support even from the government. But obviously, since let's come to my case. I mean, uh, as I said earlier, you're gonna do PhD once, right?
Hmm.
So one thing that I noticed during my undergrad was that diversity helped me grow a lot. I mean, since we are from an institute of national importance, we have diverse people around us, right?
Hmm.
Like we've
True.
had them even right now we have them. So I could learn a lot from them due to that. And in the US, what happens is that what I feel is that you have a lot of diverse people out there.
Yeah. Yeah.
So from all kinds of countries, backgrounds, and stuff.
Hmm.
So if if you are aiming for something big in your life,
Hmm.
then I think you should be around a diverse group of people.
Got it.
So that is when you grow and you sort of achieve your maximum potential. And
Hmm.
yeah, that was my primary uh, goal towards applying in the US,
Hmm.
so
Makes
that
sense.
I could grow in my life. Yeah, that is
Got
about
it.
it. Nothing else.
Makes sense. Makes sense. I will take that answer. But tell me one thing, like, so you're gonna work in the domain of approximate computing, right? Even in UCI, or is it something else
Uh,
that you're gonna work on?
so it's something like this that there are so what generally happens in the US is that, or maybe even in India. So what happens for a PhD is that the professor has some kind of a project running. I mean, some existing project
Hmm.
running, or some existing, or maybe some new project grant that he's received, and whatever you are doing is some has to some way relate to that, so that you get the funding, right?
Okay.
So in the end, okay, so I would say that uh, uh, even if you want to do research, so uh, money is an important factor towards everything. I mean,
Sure.
so once you're getting the money from someone to do something, you you definitely have to think in those kind of directions. Obviously
Okay.
you can apply different concepts towards achieving those kind of things, or maybe take up for a new dimension of the proposed research, or propose your own kind of thing out there.
Hmm.
So it's like this that I would not say exactly I would be working on approximate computing. I would probably take up something from scratch,
Okay.
and then we would see how we go about it. I mean, if we wanna apply approximate computing in that,
Okay.
if we want to
So
use something else, if we wanna combine two or three things, and we wanna see how it helps. So yeah, that is about it.
got it. So if I get this correctly, so you also will have to align yourself with your advisor's area of research, right? Like find some kind of common ground there.
Well, that is preferred. That's what I would say, because then in case you say you are publishing something, or you're doing something,
Yeah.
and you wanna register for the conference, or you wanna do something like that, and it does not really align to the project that your advisor has a grant for,
Hmm.
then he or she cannot really use that money for registering for that paper, right? So that
Got it.
is where you would find difficulty. I mean, uh, nowadays I don't think that's a very big issue, but yeah, it's always good to think in those kind of areas. But you're not restricted to like do anything. I
Understood.
mean,
Understood.
you can do anything and everything you want to do. I mean, it's all free flow of ideas, free knowledge, and all kind of stuff like
Sure.
that.
Sure.
Yeah.
Sure. Makes sense. Makes sense. So now I would come to the last question then. So we see that there's a rise of LLMs right now, and with ChatGPT and all kinds of LLMs that are coming out, Facebook, Meta, sorry, my bad, Meta and Microsoft recently released Llama 2, which is like the performance is extremely good. Actually, it is very good at generating uh, code and even other stuff. Like I've experienced tested it out. I tried to generate a few code snippets, and it was extremely well versed with what's out there. I actually tried out the quantized version, which is a smaller version of the large model that they have released. It turned out to be pretty good actually. So now I want to understand from you, like, do you see this trend helpful in your domain of research in any way, and would you
Yeah,
be
well,
using it like in any way, like going forward?
yeah. I mean, interesting question and very relevant actually, given the
Hmm.
times we're in. We live in interesting times.
Yep, yep,
So definitely, we are seeing this large growth in LLMs and uses and all kinds of stuff. So, say we want to automate something
yep,
using say electronic design automation.
yeah,
We can very well use say LLMs or even multimodal LLMs out there.
got it.
So so as to help our research,
Hmm.
and even let's also think vice versa. So once you want to run an LLM, you need a system, right?
Yeah, yeah,
So who's going to build that system?
got it. That's a
Those will
smart
be
way of
computer
thinking.
architects.
It's a very smart way of thinking actually. Like that's the problem that I'm also seeing right now. I mean, productionizing these LLMs is a challenge. I mean, some of the models that we have, not just LLMs, these large generative models, for example, which generate images and other concepts, right? They take a hell lot of time to perform inference on standard GPUs, and you will actually have to go for the high end hardware, which is
Yeah,
very expensive. So I mean,
yeah, right. I mean, if you we can trace it back to history, right? I mean, the concept of neural networks have been around. I mean, artificial neural networks have been around for from like the early 1900s.
yeah.
But when did we actually start, using them? Uh, that was like with the emergence of GPUs. That's
Hmm.
when it really
Exactly,
boomed, right?
exactly,
So,
exactly.
so you need systems to perform those kind of stuff, and
Yeah, yeah,
you see Nvidia being the major player out there,
yeah.
for GPUs and whatever. I even saw Cerebra Systems
Hmm.
having AI supercomputers using I guess AMD EPYC uh, cores out there. So
Hmm.
yeah, I mean, you need powerful and efficient systems.
You need
Also,
compute. You need
yeah,
compute actually.
you need compute, you need memory, you need communication. The basic
Yeah.
basic
it,
three
it goes it goes
aspects
hand
of
in hand. It goes hand in
yeah,
hand. So
yeah,
I'm
right.
pretty sure, like, after this discussion, people will be convinced that there won't be any dearth of jobs for folks working in the hardware domain, because if there's software coming up, you will actually need hardware to support that software as well. So yeah, so
Definitely.
yeah, before we close, like, any final points for people in college, people who want to pursue a PhD, or just to people out there, just some thoughts.
Yeah, it's like this, that you got to believe in yourself. So
Yep.
I would share a personal incident. So what happened was, I got an admit for my PhD last year only. So I was
Hmm.
about to enroll in fall 2022,
Okay.
but just before I could start, I got diagnosed with TB.
Okay. Yeah.
Also, I had some problems at work,
Okay.
like some some internal problems
Hmm.
with people,
Okay.
and also I had some financial issues due to a huge burglary taking place.
Okay.
So I mean, all of them happened to happen together.
Hmm.
It was really bad for me. I mean, I'm thankful to my family and friends, especially even you. I mean, you were there during those hard times,
Yep.
and I could. That's what pushed me up, and I could believe in myself again, and that's what I feel. I mean, I obviously I deferred my enrollment by a year, but it's fine. I mean,
Yeah, it's just a year. I mean,
yeah, it's just a
you're
year,
there.
and I've gained another year of industrial experience out
Sure,
there.
sure. I mean, true. It's
So
truly inspirational, like coming out of those hard times and still being able to pursue what you dreamt of. So I guess, yeah. I mean, that would be a takeaway as well. That just don't give
sure,
up on your dreams. Don't give up on your dreams, I would say.
exactly. I mean, things might look hard, things might look unbearable, but you gotta keep holding on to things and never lose hope.
Yep,
That's
yep.
what that's what it
I just
is.
You just need to show up and be at it,
Exactly,
whatever it may be.
exactly.
Cool, great, great, great. It was great talking to you, Rajat. Thanks for being a humble guest on our podcast. And
Oh,
yeah,
thanks.
we're looking forward to having more discussions in the future
Sure,
about
definitely. Yeah,
yeah, yeah, about your work, about whatever you might be working on. I'm pretty sure by the time this video lands, you will be neck deep in your research, PhD work. But we'll definitely try to like spare some time out and try to see if we can get more such educational discussions out for our viewers.
sure, definitely. I'm always there for this. Yeah,
Sure, sure. Thank you so much, dude. Thank you
sure.
for coming in.
Thanks, welcome. Yeah. Okay then.